Welcome to the second part of physics. In the first part of physics, we discussed words that described motion. And we looked at words like distance and displacement and speed and velocity. And all the motion that we talked about was one particular type of motion. And we used the phrase uniform motion, right? And if you don't remember what the definition of uniform motion that we used was, that an object has uniform motion if it has equal displacement in equal time intervals. It moved the same amount in the same given amount of time, right? That was our basic definition of uniform motion. Now, that is only one type of motion. So what happens when the motion of an object is not uniform? So that's what we're going to be looking at in this chapter, and we'll be adding words into our vocabulary to help describe this non-uniform motion, right? So if uniform motion was equal movement, equal displacement, and equal time intervals, non-uniform motion is the opposite of that. So there's two ways we can say that. We can say have different displacement during equal time intervals. So this is your time-lapse camera taking set. Each time you take the picture, it moves a little bit further or a little bit smaller than it did before, right? Or we can say it has different time interval for the equal displacement. So either it took longer or shorter to move the same amount of time, or same amount of distance, right? So non-uniform motion is having continuously changing velocity, right? So the technical definition, the textbook definition that we're going to write down here for change in velocity is when the speed of an object changes and or its direction of motion changes, right? So that is change in velocity, right? And is represented by a triangle. That's the Greek symbol delta, and V for velocity with a little arrow on top, right? So just like all the other change formulas, change is always final minus initial. So if you wanted to know what the change in velocity is, change in velocity is simply the final velocity minus the initial velocity, right? Now there are three different types of changes that can occur. We can have a positive change in velocity. We can have a negative change in velocity, or we could have no change. In other words, constant velocity, right? So the next little part of the notes here, we're going to describe what each one of these three different changes are. Okay? So a positive change in velocity is if the change in velocity is the same sign as the initial velocity and the speed of the object is increasing, right? It makes sense that positive change is related to an object speeding up. Before we continue on, I want to focus on this little part. The sign is the same for the change and the initial, right? Remember, velocity is a vector. What does that sign, the positive and negative, refer to? It refers to the direction of travel, right? Remember, if something's positive, it's heading to the right. If it's negatives, it's heading to the left, right? And all the different definitions of positives: up, north, east, right? So what this is saying is, if an object is speeding up and the signs of the initial and the change is the same, in other words, it's traveling. If it's traveling in the same direction and speeding up, then we have positive change in velocity. Okay? So let's just have a quick example here. So if I were to say calculate change in velocity, okay, and let's do an example here. I'll say, let's make up some numbers here. And we'll say initial velocity is at 6 meters per second. Final velocity is at 9 meters per second. Right? What is the change? Well, the change in velocity is always the final minus initial. So final velocity minus the initial velocity. We have 9 minus 6 gives us 3 meters per second, right? Notice that the change in velocity is positive. The initial velocity is positive, the 6 meters per second, right? Right? Both the same sign, both positive, right? That ended up with a positive change in velocity. A negative now change in velocity is if the change in velocity is an opposite sign as to the initial velocity, and the speed of the object is decreasing, right? So we'll say that the initial velocity is at 9 meters per second. We'll say the final velocity is at 2 meters per second. If you want to calculate the change in velocity, it would equal the final minus the initial, right? So the final was 2, the initial was 9, the change becomes negative 7 meters per second, right? So we have a negative change in velocity. That's what the looking for. And you got to notice the sign of the initial one and the final one. So initially we have positive, right? The positive 9 meters per second. And our change is negative. So they're opposite in signs. So the final situation is when we have constant velocity. So constant velocity is referring to if the change in velocity is 0, which means the object is traveling with uniform motion.